Hi, I'm Tom Walski from Bentley Systems, and I'm here in my role as a member of the ASCE EWRI Water Distribution System Analysis History Committee. We are trying to document the history of water distribution systems by talking with people who have been in the industry for quite a while and have seen a lot of things change and happen over these years. Today, our interviewee is Dave Binning, who has had a very interesting career through the Navy, the Army, the White House, several county systems, and now at AEM. So he's got some good stories to tell us about how water distribution system analysis evolved over the years. We are in Herndon, Virginia today. It's the 11th of April, 2017. Dave, tell me, how did you first get involved in water? Was it back in college, or at what point did you find water to be your love of your life?
Morning, Tom. Yeah, well, that question, I guess, is the same one that you get from a lot of folks. In college, and I was a civil engineer, and I was going to build buildings and build bridges, and that was until I took what at that time we called sanitary engineering, but I'm now not supposed to say that. I'm supposed to say that I'm an environmental engineer, but I really think I'm a sanitary engineer at heart. Took a water treatment course, and then took a wastewater course, and then finally took a course in open channel flow, and we did sewer systems and did water distribution systems and all the ancillary stuff, and that I sort of enjoyed that. So somewhere between my junior and senior year, I got a job at the university's small wastewater treatment plant, and guess I was hooked, because from that time on, that's pretty much been my little corner of the profession.
So where'd you get your degrees from?
New Mexico State University. I was a co-op student down there. That's in the southern part of the state. Took me 5 years to get my bachelor's degree, but I got a chance to see a lot of the world while I was doing it with this co-op program. I got my master's degree from University of Delaware, and that's really where I got into my first introduction to water chemistry. I also then attended a year of the Naval War College up in Newport, Rhode Island.
So most of your career, or your early career at least, was with the Navy. But the first time I ran into you, you were actually with the Army Corps of Engineers on loan from the Navy. Were the Navy guys trying to get rid of you, or what?
Yeah, that's probably the case.
You worked on the Urban Studies program, in particular on urban water supply. So tell us about your experience with the Corps of Engineers.
One of those things that you think would never happen. I basically, I'll backtrack just 20 seconds and tell you, I was one of those guys who got drafted into the Army and decided I wasn't going to be put in a green suit and sent to Vietnam with a gun. So I went down and joined the Navy, and they put me in a green suit and made me CB and gave me a gun. But I had US Navy on me. And so I was in the Navy Engineers, and I had served for about 7 years, and they asked me if I'd like to swap one tour of duty with a colleague in the Air Force and another colleague in the Army Corps of Engineers. So the three of us, for one tour of duty, literally swapped services. I got the best of the deal because I was the one that didn't go to the military side of the Corps of Engineers. They put me over, because of my background in water, put me over on the civil works side, which is basically the civilian side that does the design of national infrastructure, and got in this little program called Urban Studies. We were trying to find ways of helping operators in urban areas with their water and wastewater systems, and lo and behold, you and I crossed paths at that point.
Yeah, our first thing was the CapNet computer program for wastewater treatment design, and you helped a lot with that, as well as just moving water resources around. So then after that, you went to the public works side of the Navy. You had some pretty interesting assignments with that.
I did. As a public works officer, it's similar, if you're not familiar with it, to a facility manager at any large installation, a college campus or a large metropolitan office complex. was on a couple of different posts that were small, and then eventually wound up in Pearl Harbor at the Public Works Center there, which was a large operation, but we basically had responsibility for operating and maintaining the base facilities there.
Okay, so the next time we were kind of close to one another without even realizing it was in the 80s, where I was doing a lot of work with the Corps of Engineers, Washington Aqueduct, and you were one of the consumers of them, and you were the facility engineer for the White House. That must have been a pretty interesting assignment for you.
It was. Again, one of those things that you have no idea even existed until somebody calls you on the phone and says, "Do I have a deal for you?" I got an opportunity to work in the last 2 years of Reagan's first term and the first 2 years of his second term. Had a small staff, about 6 military types and about 4 or 5 civilian engineers. And our job basically was providing support for the various facilities that are on the 16-acre compound of the White House. Plus, we also supported the alternative locations in Reagan's term that happened to have been his ranch out in California in Santa Barbara. And then we also had some other sites that the president visited from time to time. So again, we were in facilities maintenance, but it was fun being in that atmosphere for 4 years.
So you actually interacted with the president and his family and all?
Oh yeah, it did out in California. Not a whole lot while we were in the White House compound itself, but his ranch out in California was pretty restricted. He wanted to keep that as a place where he could go out and relax. So he let the Secret Service on there. He let my guys on there that ran the electric system and the water system, and they kept the things from falling down around our heels, I guess. But I learned to chop wood. I did not learn to ride a horse very well, although it wasn't for lack of him trying. And I learned that you make sure that you ask the first lady before you paint a room, and just any color, because in the military they told me always painted beige. Everybody likes a beige room. Well, that's not always true.
Very good. What about the water system? I guess they were very secure. You probably can't even talk about all the security that were around the water systems.
As you can appreciate, the water system there was a well system, it was a groundwater system, and the distribution system was painfully simple. We had outbuildings for the farm itself, plus we had the residents, and the system that we built was a secure system, but the Secret Service actually ran it to do the water testing and the water safety on it, yes.
Okay. Then after that, you went as the Director of Naval Infrastructure for NATO, right? That was one of your other assignments. So naval infrastructure, that'd be also water systems that you ran for the NATO facilities? Or?
It was. In that case, I was on the staff of the SACLANT, which was the Navy element of NATO. The head of the Army element is actually sitting over in Brussels, but we were sitting in Norfolk. 16 nations, and each of those nations has facilities that they designate as part of the NATO forces if needed. 16 nations pool funds for facilities, and my office basically vetted what was needed as far as Navy infrastructure shore base, so the piers and the docks and the wharfs and all those things that supported the naval operations and naval airfields. Got a chance to work in 16 different countries and got a chance to work on an amazing variety of water systems. I learned then that there is no such thing as the standard way of either treating or distributing water.
Okay. So a lot of work with pipes and pumps and tanks and all that kind of stuff.
Yes, yes.
Did you do much hydraulic analysis, or do such small systems you didn't need too much?
My office didn't. What we would depend on in almost every case was the base engineer and his staff. We found some countries were very good. They had their systems mapped. They had hydraulic models built for all their systems. Other bases in other countries, it hadn't arrived yet, because we're talking now in the late 80s, the early 1990s, and some of the modeling concepts were just starting to become apparent.
Okay, then about that time you left the Navy and you started doing some consulting work for the U.S. embassies, or was that part of the Navy, or how did that work out?
No, not really. At that time, the Navy left me. I put my 30 years in, the Navy says, goodbye, son.
Okay.
And my wife says, I'm tired of moving.
Yeah.
So we actually came back to Virginia. I had spent more years of my life in Virginia than any other place, so we saw Northern Virginia as home more. And I actually went to work for Fauquier County, which is a small county system here, and went to work for their Water and Sanitation Authority as their general manager. And I basically managed that system, about 12,000 customers, water and wastewater, lots and lots of miles of pipes for very few customers, a true rural type system. After about 5 years of that, the general manager of the Fairfax County Water Authority got a hold of me and said, why don't you come to work for me as my chief engineer? So I did that and started driving east in the morning and went from a very small system in Virginia to a very, very large system in Virginia.
Okay, back to Fauquier County. So in that case, you were just extending water mains and you had small tanks and wells, or what type of system was that?
Ours was a 100% groundwater system. So in every case, we had designated development zones. The well systems that were in there, most of them went to one, if not two tanks. Most of the zones were no more than about 2 pressure zones at the most. And we were fortunate enough to be able to get most of our tanking in high areas, so we were just breaking the pressure down from the high zone down to a lower zone. It is one of those counties that does not like development. It has very strict ridgeline construction laws. They don't want to see tanks breaking the ridgeline, so I almost never got a chance to build an elevated tank anywhere that was of any really good hydraulic use to me. The biggest problems that we wound up having because of the system was the water age. Water was basically good quality, high in iron, high in manganese, so we tried treating it as best we could. And then just to try and maintain chlorine residuals on it by the time we got out to the end of our system that didn't have that much demand for some periods, that was our real challenge.
Was this the system that provided fire protection too, with the hydrants and all, or was it just rural?
It was almost pure. We had fire hydrants in, but they were flushing hydrants only.
Okay.
They were all marked that they did not serve fire protection. We didn't provide the volume for that.
Okay, so then you shifted gears and went to Fairfax, which is an ultra-urban area with all kind of elevated tanks and huge fire flows and huge buildings. So how did your philosophy about distribution systems evolve in that case?
Oh, it changed totally. I had just a wealth of really good people that were working as engineers and planners for the system. Fairfax had a really good history of their growth, and they were a new county. Our oldest system was about 40 years old. So literally, as far as water systems, especially distribution systems go, we had new infrastructure, but the growth was extremely rapid. And the downside was the growth was extremely rapid. The upside was we had the funds to be able to support intelligent planning and intelligent control of our distribution system. So we were able to do such things as sizing transmission lines intelligently, knowing that we were going to get future growth in the foreseeable 10-year future. We were able to provide pretty good looping throughout our system because of the developers in the area. We required them to loop into more than one place on the system. It was the first place that I really realized that we were really dependent upon our hydraulic modeling, and we had some hydraulic modeling going on at that time, but it was really obvious that the planners had to have that in place, and not only have it in place, but it had to be calibrated, it had to be field tested, it had to make sense if we were going to get any good data out of it. And so the period I was in that job for a little over 11 years. I didn't start the modeling, but it really expanded, and we really started using it as a powerful tool during that time.
So in a way, sizing the pipes wasn't as big an issue as staging them, right? As to when to put them
Yes.
in, is a
Yes.
bigger issue than, because when, like places where I've worked, the growth's been really slow, but in this case, you were in a situation where you were trying to guess where the growth was going to happen, and that was a big uncertainty, I guess, to try to do design.
It was, and it was kind of an interesting problem to have. If you knew that you had to have or you would like to have a 32-inch transmission main to be able to service the entire area someday in the future, but right now you didn't need that. You put in 2 lines, one now and one later. You put in the larger line because really in many cases the initial upfront cost wasn't the issue, because I could bond it out over 30 years and let the growth pick up the cost. But then you had the water age problems of the larger line. So it was that type of dynamics that was going on, as you say, in staging. When do you build a line, and what size line do you build?
Yeah, so I remember being with you on a panel discussion about water distribution system design at an ASCE conference back in Roanoke, back around in 2000. And we were talking about there were some of the researchers who were saying about optimization and pipe size was the big thing. You made the point that something along the lines of it wasn't so much the trying to get the lowest cost, but that you had a good system. You want to comment on that kind of thing?
Yeah, that's called bidding running his mouth off, is what that's called, yes. As you might recall, as I remember, the discussion was focusing very much on optimization, using modeling to help optimize pipe sizing, the costing, etc. And the only point I was trying to bring balance to was, in my experience, I had found that cost has to be just one of the considerations, that the redundancy that has to be built into the system, the support that you need, especially for future growth, all those have to come together. The bottom line is the system has to work and it has to be sustainable through its entire life. And if you really try to cut too fine at the beginning, you may find that 10 years from now you're having to go back in and retrofit, and now your cost savings is gone. So yeah, I wasn't trying to be very flippant because I thought they were making good arguments. But I think the bottom line is you got to keep in mind is you still have to provide service at every point in the future.
Okay. Very good. Okay, so in addition to normal water distribution system activities, that was about the time of 9/11, and you were highly involved in water security. You want to talk about some of the work you did, like with the RAM-W work and other things?
Yeah. Starting in about 1998, American Water Works Association, amongst others, started identifying a need to be able to come up with methods for identifying and quantifying the level of risk of various critical infrastructures, in that case water, both water and wastewater, and how risky were they and what types of things should be done. One of the developers on that was Sandia National Labs, who developed an approach called the RAM approach, and you might recall it came out as RAM-W for water, RAM-D for dams, but the framework was the same on all of them. And what Sandia was doing was trying to put the rudiments in place of a probability-based risk assessment. And we were asked as Fairfax Water if we'd be one of their beta test sites. So Sandia came out with the RAM-W, and we went through a whole discussion of how we would analyze our system. And I distinctly remember one of the questions came up about the mode of delivery, and this was strictly directed threats. These were terrorist type threats we were talking about, but the mode of delivery at that time being in vehicles, and one of the vehicles was an airplane. And so Sandia said, well, what would happen if a large airplane filled with explosives were to hit your dam, or to hit your intake section on your dam? And Benning, in his true wisdom, said that's the stupidest thing I've ever heard of. Nobody's going to waste a plane and run it into a building or run it into a structure. And so we ignored it.
Okay.
So that was my glorious start to risk assessments.
Well, I remember I was a trainer for RAM-W afterwards. I didn't realize that you were one of the people that developed it at the time. We were giving you a call.
Well, I was a beta type. Yeah.
Okay, well, still, you're a beta site for that. Yeah, that was a strange time
Now,
in our
that,
history.
that lasted until after, your original question was what happened after 9/11.
Yeah.
After 9/11, then the whole country started waking up to, we've got to have some method of being able to do risk assessments. And that's basically what I've been doing a lot of in the since 9/11, is taking that original framework that Sandia worked on, and then it got developed even more by the Society of Mechanical Engineers, the ASME, into a framework that was called RAMCAP. And the whole basis was, it's a probability-based risk assessment for critical infrastructures for all threats, whether they're directed threats or whether they're natural threats, and being able to give the owners and operators of water distribution systems and the operating companies a baseline of where their greatest risks are and where they can get the greatest reduction in risk for the investments.
Okay, so that then it evolved into an AWWA standard, J100, on risk assessment. And you're one of the authors of that, or involved at least in some development. What was your role at that development?
I was asked back in 2008 to chair a National Standards Committee, and we pulled together at that point it was under ASME, a committee made up of academics, operators, users, suppliers, equipment suppliers, to form a committee, and we actually built a standard that was then endorsed and picked up by American Water Works Association as an AWWA standard, the J100 standard for risk assessment, and then that was ultimately picked up by the American National Standard Institute to become a national ANSI standard for risk assessment in the water sector.
Okay. To what extent did hydraulic analysis play in that?
Both extremes. There are a number of areas where contamination, as an example, as a possible threat. To be able to get intelligent data on the extent of it, the system has to have especially for large systems, almost has to have a hydraulic model, so you can start to get a feeling for the affected population. And so we used, and we still use today, a local operating company's hydraulic analysis models to help us understand that. The other place that it is used is kind of on the other side of risk, which is the resilience. What is the sustainability of it? As you start losing portions of it, you lose a tank or you lose a portion of it, how long can you sustain the pressure in your system, and to what extent it then starts impacting on other critical, like the first responders, other critical areas. That has to be based on something, and hydraulic modeling works best for that.
Yes, so your work then has gone from the a really wide range of topics that you've covered over your career. But on this particular one, then I'm trying to think about how you have to have the model sort of incorporated with operations. It can't just be something you do for master plan and put on a shelf. That it really needs to keep you need to keep your model up to date.
Yes.
As far as that's concerned.
If the model hasn't been calibrated out in the field, and if it's not used regularly, then it stands a good chance of maybe even giving us misleading information. But more and more, for big systems anyway, and as you're aware, AWWA classifies as an EPA about 400 to 500 systems being the really big systems. Those people are using their hydraulic models, and we can depend a lot on that for good data. Smaller systems, it's really, really difficult for a little bitty system, especially a rural system, to be able to have that type of an asset.
Yeah, so the work though has evolved more from just contamination to general risk, hydraulic risk, pipelines bursting, and
yes.
Pump stations losing power. So it's a whole broader scope than just contamination now.
The standard is a 5-year standard. Now it's every 5 years it has to be reviewed and updated. So we've just are in the process of completing the first 5-year update of the standard, and we are pulling in asset management, the actual look at the materials of the piping itself. We're trying to take a look at accidents that occur, because those are all threats that occur to the system. And as you say, in that case, then your hydraulic modeling becomes an integral part of being able to understand what might be happening.
Great. Okay, so then, in addition to all this, you think you're busy enough, but you're also involved with George Mason University as an adjunct faculty member.
Yes.
So you want to say something about teaching hydraulics and your view of it? I suppose we mostly have had researchers, people being interviewed, but you're not a researcher so much as the actual guy who talks about real design and operation.
I'm starting my 17th year at George Mason, and they've been kind enough to ask me back for some benighted reason. In the spring, I usually teach a sophomore class in basically hydraulics, which, if you've got as much gray hair as I do, we used to take a fluids class, and then we took a hydraulics class. Well, they're all together now. In civil engineering, we only teach compressible fluids. We don't, incompressible fluids, we don't teach compressible fluids. But it's fun to watch those students, because in my case, that's almost one of their very first engineering courses. Up to then, they've been slogging through all the math and science and physics. That's the first time it's an engineering course. And to try and see that your calculator gave you 17 digits after that decimal, but they don't mean anything, and you really think you can get a pipe in 18.67 inch diameter, probably not, and what that means, that's kind of an eye-opener for them. And then you walk into the lab, and they can actually play with it, and they actually see that, oh, the Bernoulli effect it does work. It actually, you're not just blowing smoke at me. It actually works. Or there is pressure losses that goes through these pipes. Yeah, I love it. Then in the spring term, I teach a couple of courses. I teach one in water plant design and wastewater plant design. I teach another one in distribution system design. And from that one, we start with modeling through the design, through the operation, through the troubleshooting of it. At that time, the students are seniors and graduate students. And to be honest with you, that's kind of fun. In that case, you don't do a lot of teaching. You just throw out a topic, and they sit there and sort of drag it along for the next several hours.
Yes, that's got to be a labor of love for you too, because I know that as an adjunct myself, you don't really get paid big bucks for doing it. You got to do it because you want to give back.
I do. That's what I do for my profession.
Yes, but you also have a full-time job here with AEM. So
yes.
what do you do in that position?
AEM is a consulting firm here in Northern Virginia. We are basically a database designer and management company, except for about 5 of us that are civil engineers, are engineers, civil, electrical, and mechanical. They sit back in the corner, and we do that because our president and CEO is a civil engineer. And she says, I got a great company here, but I want civil engineers working for me. But what we have been doing for a number of years, and what I've gotten very involved in, is working for the State Department. And the State Department will send me out to sites that are having problems with either their waste treatment plants or their water treatment plants or their distribution systems to do troubleshooting, and then to put on training courses while I'm out in the field. So it has been a real eye-opener. They never send me to London and Oslo. I go to a lot of West Africa countries and tremendous people. The manager is usually a U.S. engineer, but all of his staff are local nationals. And they are bright, they're dedicated, they're hardworking. Some of the people we have working for us have trouble reading their own language, much less English. So that's kind of, you're teaching and you're showing them how to operate, which can be some of the distribution systems with the SCADA systems tied to them for control and for monitoring. It's a little bit of a challenge for them, but they do a good job.
Okay, so at a time when most people are winding down their careers, you still seem to be quite active. So what do you see as the future coming up in water distribution system analysis, in particular, and water in general?
I wish I had a great insight of where it is going. Water distribution systems are going to do nothing more than get more and more automated as we put more and more instruments on them. You're starting to see people instrumenting large pipes to be able to watch their progress. We had a whole set of, even 10 years ago, PCCP pipe that was of concern to us. and we basically retrofitted it with strain gauges, instrumentation, so we could just monitor what was happening on that pipe. I've recently seen where there are other type sensors that are out there to be able to real-time test corrosion, be able to try and get a feeling, can I be proactive and change out pipes before they blow up on me under the highway. I think you're going to see that in distribution. You're going to see better, more cost-efficient, more effective pumping systems that are out there, and the instrumentation and the control systems to go along with that. You're going to see better security on them, so you can't get outside hacking of these systems as easily. I really think that's where we're headed. Where are we headed on water quality? I don't have a clue. I know the bottled water industry is still growing like crazy, and I think it will. People use our water without thinking about it, and that's wonderful. That's the way they should. But I think we have a whole generation that is also very much used to having a bottled water with them, and instead of filling it at the tap, they're going to the store and buying it. So my challenge is still out there to try and convince them that that's not the way to do it.
Yeah, I just fill my bottles.
No, that's
yeah.
No, you buy the label. You pay a lot of money for that plastic bottle and that label, apparently.
Yeah, it produces a lot of solid waste along the way. Yes.
Yeah, you do.
Okay, Dave. Well, this was just an excellent interview. I really appreciate taking the time to meet with me and provide a different perspective than a lot of the other people we've had interviewed in this program. And it's great to have this, a different view than a lot of other folks. And I think we really appreciate you taking the time to meet with me.
Tom, I appreciate it. Thank you.